Hello everyone, I am Sandeep Mahadev Parki. Today I am going to deliver seminar on my topic use of catalyst in a chemical reaction and their mechanism of action. Here the flow of representation which contain introduction, catalyst, characteristic of catalyst, type of catalysis, mechanism of catalysis, and last one is use of catalyst in various chemical reaction. These are the content. First of all, what is the meaning of catalyst? Catalyst is a chemical substance which increase the rate of reaction and decrease the activation energy known as catalyst. Here the definition is which contain a chemical substance which increase the rate of reaction. That means ऐसा substance की जो क्या करता है reaction का rate बढ़ाता है लेकिन activation energy कम करता है. Such type of substances known as a catalyst. These catalysts are of two types. One is a positive catalyst and second is a negative catalyst. Here the certain terminology used in a catalyst. First is activation energy. What is the meaning of activation energy? Activation energy is defined as it is a minimum amount of energy required to activate reactant molecule known as activation energy. And second one is catalysis. What is the meaning of catalysis? This terminology related with the catalyst. That means the process lowering the activation energy and increase the rate of reaction. This process it is known as a catalysis. In the next slide, we studied about the characteristic of catalyst. There are the main characteristics shown by the catalyst during the process or reaction. One is the rate of reaction. Catalyst is the chemical substance which increase the rate of reaction. Second one characteristics which are related to activation energy. It decrease the activation energy. That's why we required the minimum time to complete the reaction as well as increase the rate of reaction. Third one is catalyst does not initiate the chemical reaction. Second one is a catalyst is not consumed in the reaction. That means they are remain suspended throughout the whole reaction. That's why we use catalyst again and again. These are the main characteristic of the catalyst. And the next one is catalyst react with reactant to form an intermediate and at the same time facilitate the production of the final product after the whole process. And the last one is a catalyst which can be regenerated. That means in the chemical process the catalysts are used. During the chemical process, they are remain suspended throughout the whole reaction. That's why we use the catalyst again and again and again. These are the main and important characteristics shown by the catalyst. Here, there are the two type of catalysis process. One is a homogeneous catalysis. Second one is a heterogeneous catalysis. What is the meaning of homogeneous catalysis? The catalysis process in which रिएक्टेंट एज वेल एज कैटलिस्ट बोथ आर इन द सेम फेज. म्हणजे मतलब क्या होता है, रिएक्टेंट हमने सॉलिड स्टेट में लिया तो कैटलिस्ट भी हम सॉलिड स्टेट में लेंगे. रिएक्टेंट हमने गैसियस स्टेट में लिया तो हम कैटलिस्ट भी गैसियस स्टेट में लेंगे. मतलब रिएक्टेंट एंड कैटलिस्ट बोथ आर इन द सेम फेज. दैट्स व्हाई इट इज कॉल्ड एज अ होमोजेनियस कैटलिसिस. कंसिडर द एग्जांपल ऑफ सल्फर डाइऑक्साइड react with oxygen gas. That means oxidation of the sulfur dioxide gas in the presence of NO. Here sulfur dioxide oxygen in the same phase or same state. Also the catalyst used in this reaction are in the same phase, that means gaseous, and the product obtained is SO3 which are in the gaseous state. Second one reaction is if ester on hydrolysis, that means both ester and water both are in a liquid phase, then H plus ion, that means acid, which are in also liquid state, then the product obtains such type of acid and alcohol. In this process, in this catalysis process, reactant as well as catalyst both are in equal phase or in same phase. That's why it is called as a homogeneous catalysis. Second one is heterogeneous catalysis. What is the meaning of heterogeneous catalysis? The heterogeneous catalysis is the process in which reactant as well as catalyst both are in different phase. That means दोनों की भी फेज सेम नहीं रहेंगी, तब हम उसको क्या बोलते हैं, heterogeneous catalysis. In this slides here the reactant is hydrogen peroxide H2O2 in a liquid phase, but the catalyst used in this reaction platinum are in a solid phase. That means reactant phase are differ from the catalyst. That's why it is called as a heterogeneous catalysis reaction. मतलब यहाँ पर दो प्रकार के हम कैटालिसिस प्रोसेस देखेंगे, एक है होमोजीनियस, दूसरा है हेट्रोजीनियस. होमोजीनियस में बोथ रिएक्टेंट और कैटालिस्ट कैसे फेज में रहेंगे, बोथ आर इन सेम फेज. बट हेट्रोजीनियस नाम में रखा है इसमें हेट्रोजीनियस, जीनियस मीन्स डिफरेंट डिफरेंट फेज. डिफरेंट फेज में हेट्रो मीन्स डिफरेंट, डिफरेंट फेज में मतलब नॉन यूनिफॉर्म, एक सॉलिड रहेगा तो दूसरा गैसेस रहेगा, गैसेस रिएक्टेंट रहेंगे तो सॉलिड कैटालिस्ट रहेगा. या फिर दूसरी रिएक्शन देखो, यहां पर नाइट्रोजन हाइड्रोजन, देयर इज अ फॉर्मेशन ऑफ अमोनिया गैस. दैट मीन्स अमोनिया गैस प्रोड्यूस इन द by the reaction of nitrogen and hydrogen gas under the higher pressure. But this reaction carried out in the presence of Fe. Here Fe are the solid. That's why there are the different phase shown by this reaction. Hence it is called as a heterogeneous catalyst. Next one is, there are the certain mechanism involved in the catalysis process. In the presence of catalyst, less free energy is required. That means the minimum amount of energy required to carry out the reaction to reach the transition state, but the total free energy from the reactant to product does not be changed. मतलब टोटल एनर्जी जो भी फ्री एनर्जी रहेंगी रिएक्टेंट से प्रोडक्ट तक जाने की वो चेंज नहीं होंगी, बट एक्टिवेशन एनर्जी डिक्रीज होंगी. मतलब यहां पर हमने फोकस कहां पर किया, लेस फ्री एनर्जी रिक्वायर्ड टू कंप्लीट द रिएक्शन. सेकंड वन इज कैटलिस्ट में भी पार्टिसिपेट इन मल्टीपल, मतलब एक कैटलिस्ट हम हर जगह पर यूज कर सकते हैं दूसरी रिएक्शन में. मतलब री एंड री, दैट मीन्स डबल डबल हम इसको यूज कर सकते हैं. थर्ड वन इज अ कैटालाइज रिएक्शन हैव द लोअर एक्टिवेशन एनर्जी, दैट मीन्स रेट लिमिटिंग फ्री एनर्जी ऑफ एक्टिवेशन देन द करस्पॉन्डिंग अनकैटालाइज रिएक्शन. हम दूसरे स्लाइड्स में ग्राफ में इसका विवरण करेंगे कि हम कैटालिस्ट का उपयोग करने के बाद जो भी रेट ऑफ रिएक्शन वो कैसे बढ़ेंगे, एक्टिवेशन एनर्जी कैसे डिक्रीज हुई, ये हम अगली स्लाइड में पढ़ेंगे. हियर द हायर रिएक्शन रेट एट द सेम टेम्परेचर एंड फॉर द सेम रिएक्टेंट कॉन्सेंट्रेशन. नेक्स्ट वन इज, एज द इन द केस of any other chemical reaction, the reaction rates depend upon the frequency of contact of reactant in the rate determining step. We know that the slow step is known as a rate determining step. These rate determining step carried out or oozes out or sort out by using certain catalyst. Here the rate of reaction which can be increases and the activation energy decreases. These are the main important parameter or characteristics shown by the catalyst during the chemical process. Although the catalysts are not consumed by the reaction itself, they may be inhibited, deactivated or destroyed by the secondary process. These are the mechanism and the main process shown by the catalyst during the catalysis process. Here the energy profile diagram for the catalytic reaction and uncatalytic reaction. Here on the y-axis there is a potential energy and on axis there are the reaction progress or rate of reaction. This red color line shown by the catalytic reaction and the blue color line show the uncatalyzed reaction. Here by using two graph or by using these two line, it is show that ki during the reaction when we use the catalyst, then the activation energy, that means EA with catalyst get on the decreases as compared to uncatalyzed reaction. Here the uncatalyzed reaction which are shown by the blue color line, here blue color line indicate that reactant, when reactant molecule get activated, then it required the more amount of energy for the activation. That means activation energy of reactant molecule is increases are higher in absence of catalyst, but by using of catalyst the activation energy of the reactant molecule get decreases. That means we require the minimum amount of energy. That means it is atom economy process or the save energy process. That's why they are beneficial to green chemistry principle or green chemistry. Okay, here the mechanism of heterogeneous catalysis of the chemical reaction. Adsorption propose 5-step mechanism for the catalyst. These 5 steps are as follow. The steps are as follow. Here the step number 1, introduction and diffusion of the reactant molecule on the catalytic surface. Second one, Second one is a adsorption of the reactant molecule on the catalytic surface. Third one is a formation of intermediate. These are the main and important parameters during the chemical process. Fourth one is a distortion of the product's molecule. And last one is a diffusion of the product molecule away from the catalytic surface to form a final product. ये अभी स्लाइड हम यहाँ पर देखेंगे, यहाँ पर हमको पूरा समझ में आ जाएगा. कैटलिस्ट रिएक्ट विद द रिएक्टेंट टू फॉर्म अ इंटरमीडिएट and the same time facilitate the production of final product. After the whole process, a catalyst which can be regenerated and we can use again and again. Here the process, spontaneous process reaction in which S are converted to P. Here S means what? Substrate converted into product without or absence of catalyst. But in a catalyzed reaction, when S plus C is equal to P plus C, here S stand for the substrate, P stand for the products, and C that means catalyst. Here catalyst is provide the pathway or provide the surface area for the कन्वर्शन ऑफ रिएक्टेंट मॉलिक्यूल इनटू प्रोडक्ट. मतलब रिएक्टेंट प्रोडक्ट में कन्वर्ट होने के लिए जो भी रिएक्शन फास्ट होती है, एक्टिवेशन एनर्जी कम करने के लिए जो कैटलिस्ट रहता वो केमिकल सब्सटेंस क्या करता, रिएक्शन के लिए पाथ प्रोवाइड करता, सरफेस प्रोवाइड करता. अब देखो यहां पर ब्लैक कलर का डॉट और रेड कलर का डॉट, these are the reactant material. These reactant material react in the presence of yellow color dot, that means catalyst. This catalyst carried out the reaction or attachment or reacting molecule react with each other. They provide the pathway or adhesive pathway, and after the completion of reaction the catalyst they are removed and we can use this catalyst again and again. These are the main important mechanisms shown by the catalyst during the process, and this process it is nothing but a catalysis. There are the certain catalyst used in a various process. Use of the catalyst in various chemical reaction are as follow. Here the catalytic process and their catalyst process. Formation of ammonia, that means ammonia synthesis, carried out in presence of iron. That means iron play an important role for the preparation of ammonia by using nitrogen and hydrogen gas. Second one is the sulfuric acid manufacture done in the presence of nitrogen oxide and platinum. Third one is the cracking of petroleum carried out in presence of zeolite, ZSM. Next one is the hydrogenation of unsaturated hydrocarbon. That means unsaturated hydrocarbon converted into fats and oil in the presence of nickel, platinum or ranine nickel or palladium. Oxidation of hydrocarbons in the automobile exhaust carried out in the presence of catalyst copper, vanadium, platinum, palladium, so on. Isomerization of N-butane to isobutane, that means isobutane formed by using the N-butane. These isomerization carried out by the presence of aluminum chloride or hydrogen chloride. These are the certain list of catalysts. Also there are the various process like HDPE, high density polymerization of ethene, done by using the Ziegler-Natta catalyst. Ziegler-Natta catalyst is a combination of triethyl aluminium and ट्राइथिल एल्यूमिनियम और उसके साथ हम यूज कर सकते एक दूसरा निकेल या फिर ऐसा कुछ तो भी है जो हम यूज करके हम क्या बना सकते हैं उनमें से हाई डेंसिटी ऑफ इथिन बाय यूजिंग पॉलीथीन, बाय यूजिंग इथिन टू पॉलीथीन, मतलब HDPE, हाई डेंसिटी पॉलीमराइजेशन ऑफ इथिन डन बाय यूजिंग द Ziegler-Natta catalyst. Next one is thank you for very much for giving me such type of opportunity. Thank you sir. Thank you.